Good afternoon students. In today's class we are going to start with exercise 7.9. In that the first main question, it is integral -1 to +1 x plus 1 dx. So let us solve the given integral. Solution. So take this as I which is equals to integral -1 to 1 x plus 1 dx. So integrate them separately now. So what is the integration of x? It is x square by 2. So I write x square by 2 plus, what is the integration of 1? It is x. So I will be writing x. So I apply the limit now. So here it has to be -1 to +1. So now I which is equals to, so here, so what was the second fundamental theorem? F of x, capital F of x, a to b. Then we had written f of b minus f of a, upper limit minus the lower limit. In place of x we have to write upper limit. See here, 1 square, it will be 1. So 1 by 2 plus 1, this is upper limit, minus in place of x we have to write -1. -1 the square, it will be +1. We get 1 by 2. Then plus, here in place of x I have to write -1. So plus into minus, it is minus. I can write minus directly now. Let us simplify this. I which is equals to, so here 1 by 2 plus 1, then multiply minus with these two terms. -1 by 2, minus into minus, plus 1. So plus 1 by 2 minus 1 by 2 get cancelled. So 1 plus 1, it is 2. So I which is equals to 2. So this is all about the first problem in the exercise 7.9. Let us go for the second one. So the 7.9 exercise is very much simple. We'll solve the next question, that is the second one. It is integral 2 to 3, lower limit is 2, upper limit it is 3, 1 by x dx. So let us take this as I. So I'll be taking this as I which is equals to integral 2 to 3, 1 by x dx. So what is the integral of 1 by x? It is log x or log mod x. I which is equals to log mod x. Then apply the limit here, 2 to 3. And remember one more thing, don't write plus c in definite integrals. So I which is equals to log mod, in place of x we have to write 3, it is mod 3, then minus log mod lower limit, it is 2. Now this is in the form of log x minus log y, it is log x by y. I which is equals to log mod 3 by 2, or you can simply write it as log 3 by 2. So this is the answer for the second problem. Then we'll go for the third one. Let us solve the third question of the exercise 7.9. It is, so we'll write the third question. Integral 1 to 2 4x cube minus 5x square plus 6x plus 9 dx. So this is the given question and we have to solve this integral. So let us solve this now. I which is equals to I which is equals to integral 1 to 2 4x cube minus 5x square plus 6x plus 9 plus 6x plus 9 dx. So here overall we have 4 terms and we should integrate them separately. Let us integrate them separately. 4 I write it as it is, then integration of x to the power 3 will be x to the power 4 divided by 4, then minus 5 I write it as it is, integration of x square will be x cube divided by 3, x to the power 3 divided by 3 plus 6 is a constant, write it as it is, then integration of x will be x square divided by 2 plus 9 is a constant, write it as it is, then integration of dx will be x. So here we have to write the lower limit and the upper limit 1 to 2, then I which is equals to, so we'll simplify this now, 4 and 4 get cancels, here 2 ones are 2 3s are. In the next step we'll apply the limits. So here we have x to the power 4 minus 5x cube divided by 3, then we have plus 3x square and then we have plus 9x. Now let's go for upper limit minus the lower limit, I which is equals to, so in place of x we have to write, I have to write 1 to 2 here. So first we have to write 2 in place of x. So 2 raised to 4 it is 16, then minus 5. Here we have to write x cube, that is 2 cube, it will be 8. So we get 8 divided by 3, then plus 3 times, so here x square, that is 2 square, it will be 4, 3 into 4 plus 9 into 2 it is 18. This is upper limit minus the lower limit. In place of x we have to write 1. So we get 1 here. 1 raised to 4 it is 1. Then minus 5 by 3. Then plus 3 plus 9. So we have to simplify this particular term to get the final answer for the given integral. So I which is equals to, let us simplify this now, 16, then minus 8 into 5 it is 40 divided by 3, then 3 into 4 it is 12 plus 18, 12 plus 18. So now multiply minus with all the 4 terms. See here we get minus 1, or else you do one thing, 1 plus 3 it is 4, 4 plus 9 it is 13, so we get minus 13. I am writing it directly. Then minus into minus it is plus 5 by 3, so plus 5 divided by 3. So now I which is equals to, so these two are the like terms and remaining you have to add. These 3 terms must be added and this has to be subtracted. Then see here, 18 minus 13 it is 5, 5 plus 12 it is 17, then plus 16 it is 33. So I write 33 here, 33, then this has to be, the denominator is same, that means the LCM will be 3. So 5 minus 40 it will be minus 35, divided by 3. So now in the next step I which is equals to, take up the LCM, 3 will be multiplied with 33, we get 99 minus 35, 99 minus 35 divided by 3. So I which is equals to 99 minus 35 will be 64 divided by 3. So this is the answer for the third problem. Well, let us solve the fourth and fifth question. See here, I will be taking this as I which is equals to integral 0 to pi by 4 sin 2x dx. So this is in the form of integration of sin ax dx. So that is nothing but minus cos ax by a. So here I which is equals to minus cos, it is 2x divided by 2, then apply the limits, it is 0 to pi by 4, then I which is equals to upper limit. So see here, minus cos 2, in place of x I have to write pi by 4. So it is pi by 4 whole divided by 2. This is upper limit, minus the lower limit. This minus we have to write it as it is. Minus cos 2 into 0, it is 0 divided by 2. Simplify this now. So here 2 1s are 2 2s are. So overall what do we have now? We have minus cos pi by 2. Cos pi by 2, it is 0. 0 by anything is always 0. So 0 minus into minus, it is plus, then cos 0, it is 1 by 2. So 0 plus 1 by 2. So overall the answer is 1 by 2. This is the answer for the fourth problem. Let us solve the fifth question now. So take this as I which is equals to integral 0 to pi by 2, then cos 2x dx. So now this is in the form of integral cos ax dx. So it is nothing but sin ax by a. So sin a it is 2, sin ax by a, then apply the limits, it is 0 to pi by 2. Now upper limit minus the lower limit, I which is equals to upper limit sin 2, in place of x I have to write pi by 2, it has to be pi by 2, then divided by 2, this is upper limit, minus the lower limit, in place of x I have to write 0. 0 into 2, it is 0. So overall we get sin 0 divided by 2, sin 0 divided by 2. So here I which is equals to, now 2 and 2 get cancels, we have sin pi, that means sin 180 degree. What is the value of sin pi? It is 0. 0 by 2, it is going to be 0, minus sin 0, it is 0. So overall we have 0. The value of this integral is going to be 0. So this is all about the fourth and fifth question of the exercise 7.9. Well, let us solve the sixth and seventh question of the exercise 7.9. So I'll be taking this as I which is equals to integral 4 to 5 e power x dx, e raised to x dx. So now what is the integration of e raised to x? It is e power x itself, then apply the limits here, it is 4 to 5, then I which is equals to, it has to be upper limit, that is e raised to 5, upper limit minus the lower limit, it is e raised to 4. In these two terms we have e raised to 4 common. So here I can write e raised to 4 outside, then e minus 1. So e means it is e power 1. So we get back the previous term if you multiply this e raised to 4 with these two terms. So this is the final answer or the NCERT answer for the 6th one. Let us move on to the 7th question. Well, I which is equals to integral 0 to pi by 4, it is tan x dx. Tan x dx. What is the integration of tan x? It is log mod secant x or minus log mod cos x. So see here, I which is equals to log mod secant x, log mod secant x, then apply the limits here. It is 0 to pi by 4. So now I which is equals to, it has to be upper limit minus the lower limit, log mod secant, in place of x I have to write pi by 4, log mod secant pi by 4 minus log mod secant 0. Is that clear? So now I which is equals to log, so secant pi by 4 is the reciprocal of cos pi by 4. Cos pi by 4 it is 1 by root 2. Secant pi by 4 will be root 2. Then minus log. What is the value of secant 0? Cos 0 it is 1. Reciprocal of cos 0 it will be again 1. So here we get 1. What is the value of log 1? Log 1 means it is 0. So here the log 1 value is going to be 0. I which is equals to log root 2 can be written as 2 raised to 1 by 2 minus 0. So here it is in the form of log x to the power n. That means n must be written in the beginning. So that will be our final answer. I which is equals to 1 by 2 log 2. So this is the required answer for the 7th question.